Hi there, this is Penelope. This is a video on integration by substitution for DE4102. Now, sometimes when we go to integrate, it helps to replace one part of the expression to be integrated with a simpler one. This will involve making an algebraic substitution rather than a trig substitution in a couple of the earlier videos that we've looked at. So the expression to be integrated is written in terms of a new variable, say u, instead of x. Two important points we need to check, and these both arise because all of the expressions in x must be replaced by expressions in u, which includes the dx part. We've got to adjust for integrating with respect to u instead of x as in the original problem. Here's how you've got to set out your working. First up, we say, look at the bit in the brackets and let u equal that. So u equals 5x minus 1. We know that ultimately we've got to replace dx, so we need to find dx. So let's look at differentiating. Then if we rearrange that derivative, we can find dx in terms of du. Put it all together. So now we've got the integral of 5x minus 1 cubed is going to be the integral of u cubed times a fifth du. What we've got now is something that we can easily integrate. The fifth stays. The integral of u cubed is u to the 4 over 4. We can tidy that up, u to the 4 over 20. And then we replace u with what we started with. So it would be 5x minus 1 to the power of 4 over 20 plus c. A slightly harder one. Let's look here. Let's use this bit as our substitution. And the same thing, we need to find dx. So all we can start off with is to find du by dx and then rearrange that to find dx. Okay, put it all together. So that's going to be the integral of 1 over root u times a third of du. Put the third out the front if you like. Whoops. Put the third out the front if you like. Why don't I make that u to the negative a half? And then I can integrate it. So it's a third times. Now it's u to the power of a half over a half, which is the same as times 2. And I can put it back together to root u over 3. And if I substitute back in with what I started with, I'm done.